Hello. In this session, I will show you how to develop multiple regression model and how to interpret the outcome, then how to do or test the diagnostic for the model. So the variable, we have three variables such as GDP as the dependent variable, unemployment rate and foreign direct investment as independent variable. Our data is time series data 1980-2016, as you can see it here, which is 37 observation, meaning that a problem of serial correlation may appear. So we shall be checking serial correlation for this model because our data time series. Then normally serial correlation occur in time series. So normally serial correlation occur in time series data, not in cross-section data. Then I check for the diagnostic, check for normal distribution, and also I check for heteroscedasticity. The question here, what are our variable appear here? GDP, unemployment, foreign direct investment, and then we can run the regression model. How to run the regression model? I'll go to analyze, regression, linear, and then move GDP as dependent variable, unemployment rate and inflation, foreign direct investment as independent variable. Then select statistic, choose the Durbin Watson Statistics to check for serial correlation because we have a time series data, and then press continue, then the question here, our plan is to see whether the foreign direct investment and unemployment rate can influence the dependent variable GDP. Then we check the model fit as we mentioned. If the data is time series, we have to select Durbin Watson Statistics, and normally serial correlation occur in time series, not in cross section. Then continue, as we mentioned, press plot, and then move the Z predict to x-axis and Z to y-axis, and then press OK. Continue and press OK. In this case, and then you can also press save, select student dice and continue, then press OK. So here what we have, the dependent variable, as you can see it, is GDP, independent variable, foreign direct investment and employment rate. From this we can plot, we shall check whether we have heteroscedasticity or not. And then, as we mentioned, we check save and select student dice as we mentioned earlier, and then press OK. And this is the outcome. Here there are five. As we mentioned, there are 5 types of residual. From this residual, I chose a student dice or standard dice. Select one student dice residual to check whether the residual normally distributed or not, and for good model residual should be normally distributed. Then the outcome is here. The first one, we have to interpret model summary, and then we'll go to ANOVA and coefficient. Now, how to interpret model summary? First, I talked about model summary, as you can see it here. Then I'll check RC 92.8%, and we have a three variable. GDP is dependent variable, and foreign direct investment and unemployment rate as independent variable. So I can say 100% minus 92.8, remaining about 6%, and this is 92.8 minus 100 minus 92.8 equals 6.2, which is mean that by R squared 92.8 fluctuation in GDP can explain by jointly by foreign direct investment and unemployment rate. Then what about 6.2% is the approximate value. It means that 6% fluctuation in GDP as dependent in GDP as a result can explain by other variable which is excluded from other than foreign direct investment and unemployment rate, which is excluded from the model. So here, what is the summary? Outside factor explains 6% because R squared 92.8%, meaning that the model very nicely fitted, so we can say that if the value of R squared more than 6%, meaning that the model is nicely fitted the data, we are happy about it. So what about the second table is ANOVA. As you can see it, there is F statistic corresponding to p-value. We have a statistic corresponding to p-value, and normally we say that if p-value is less than 5%, meaning that we reject null and accept the alternative. What is null? Null is the variable foreign direct investment and unemployment rate jointly cannot influence the dependent variable GDP and the alternative. Both variables jointly can influence the dependent variable GDP. So in this case, meaning that one p-value less than 5%, meaning that we reject null and statistically significant, meaning that the two independent variable, foreign direct investment and unemployment rate, significantly explain the dependent variable GDP, as you can see it here. Now we look to the regression model to see whether the coefficient is statistically significant or not, unemployment rate and foreign direct investment. We have two variables, unemployment rate and foreign direct investment, so I go to first to the unemployment rate. Unemployment, as you can see it here, p-value is more than 5%, which is 6.1%, has no influence on the dependent variable GDP, and this is negative and not significant. So this has unemployment rate has no influence on the dependent variable GDP as far as p-value 6.1, which is greater than 5%. But inflation rate is positive coefficient influence the dependent variable positively and statistically significant. And this is how, so out of these variable, at least one variable is significant. So 50% of the variable significant, that is foreign direct investment. So we accept the model, and our plan is at least 50% of the variable significant. Then we check whether the model has heteroscedasticity or not. We can check it here from the graph here. Here you can look at the two variable vertical axis and horizontal axis. As you can see, we can see the scattered vertical axis, and Z predict in the axis, horizontal axis. Here we can see the residual start from the top left, from the top left hand side, goes down and then goes up. I suspect that there is a heteroscedasticity, so the residual are going down and then going up. This is, we call it system pattern. Now, the question here, how to solve or to remove heteroscedasticity problem. To remove heteroscedasticity problem from the model, one way is logarithm transformation to remove heteroscedasticity, meaning that we shall convert all the variable into log and then we shall run the regression again. Actually, there are many ways to remove heteroscedasticity, and I posted a video to explain the detect of heteroscedasticity and how to remove it from the model for separate video and more detailed, which is fully explained. Then we shall be checking now which is whether our residual normally distributed or not. Last time we saved the standardize or student-dize, any one of them. Then I have to go to analyze, descriptive statistic, explore, and then I put standardize. Sorry, this is before the transformation. This is the one without transformation, and put it in the dependent variable, and then select the plot and check histogram and normality, then press OK, continue, and press OK. So what we have here, we have two tables. In this case here, when we test for normal distribution, we usually use the mathematical approach, which is here, Kolmogorov and Shapiro. We are looking for the p-value greater than 5% for both or for one of them. If both of them are greater than 5%, it means that the data is residual are normally distributed. But if the p-value is less than 5%, meaning that the residual are not normally distributed, as in our case here. For Kolmogorov, p-value less than 5%, which is 1.1 less than 5%, meaning that the residual are not normally distributed, and the same for the Shapiro, 1.4% less than 5%, so the residual are not normally distributed. But sometimes if we have one of them less than 5 and the other greater than 5, this is your decision to select one of them, and then you mention that residual is normally distributed according to Kolmogorov or Shapiro. Another test you can do it here mathematically from the descriptive. You can use skewness and quarters. If you divide statistical for skewness on the standard error and quarters statistic on standard error, and you get the value between minus 1.696 and 1 plus 1.96, it means that the residual are normally distributed. But if otherwise, the residual are not normally distributed. So in this case, we have the mathematical approach can confirm the result, Kolmogorov, and the graphical approach can not confirm the result. In this case, I talk about mathematical, which is already mentioned that we talked about it, and then what is happening, both tests is telling the residual are not normally distributed, which is now to the histogram, and here you can look to the histogram. As you can see it, the plotting is not normal, so the approach is telling that some same thing residual are not normally distributed. So here we can see also the other one, normal QQ, as you can see it here. Normal QQ plot of studentized residual, you can see it, and this is simple interpretation. Our plan is if the circle here is falling on this fitted line, which is all this observation, if falling on the fitted line, we can say the residual are normally distributed. So if this circle is not falling on the line, we can say our residual are not normally distributed. And finally we check that last one, the graphical, as you can mention it here, the box plot. Normally when the median in the middle, residual are normally distributed. But if the median, and then we can say that normally we say that when the median in the middle or in the center, we say that our residual are normally distributed. But if the median close to the top, we say that particular plotting negatively skewed and residual are not normally distributed. And when the median close to the bottom, we say that particular plotting positively skewed and residual are not normally distributed. So in our case, as you can see it here, our decision is that mathematical and graphical approach are telling the residual are not normally distributed. But our model has two problems. The first problem, our model has the problem of heteroscedasticity and the residual are not normally distributed. Meaning that I have to remove this problem. I have to convert all the variable transform the variable into logarithm. How? I'll go to transform, compute variable, and here we put log GDP. We transfer it here, GDP, press OK, and then transform again, log unemployment rate, then move unemployment rate to this square unemployment rate and press OK. And the last thing we have to transform, compute foreign direct investment, and then move foreign direct investment here and then press OK. Then we can see that the data is transformed into logarithm. So what we shall do now, after we transform all the data into, or the variable into logarithm, then we have to run the regression again. We use the same process for the other as before. So how to run the regression? I go to Analyze, Regression, Linear, and then Statistic. Of course, I mentioned it here. This is, we have to reset and put the log GDP as dependent variable, log unemployment, and log foreign direct investment as independent variable. Then I go to Stat, then select Durbin Watson because it is a time series, and then I'll go to Plot, continue, go to Plot, select Z predict as X axis and Z visit as Y axis, and then continue, select Save, Standardize, because here we have 5 residual, many residual, you can select any one of them. I select Standardize, you can select Studentize, and so on. Continue, and then press OK. The outcome here, as you can see it, for the logarithm, and what we shall, I put logarithm as a dependent variable, logarithm GDP, and logarithm foreign direct investment, logarithm unemployment rate as independent variable, and then we run the regression and choose the same method as before. So the outcome is here. The model summary first, you can see it here, R square is 94.2%, and this means that here we can say that is R square 94.2% is quite high, so we are happy about the model. So the model is nicely fitted. Then we talk about ANOVA, as you can see it here, the value of every statistic and corresponding to p-value, where p-value is less than 5%, meaning that we reject null and accept alternative, meaning that logarithm foreign direct investment and logarithm unemployment rate jointly can influence dependent variable as a dependent variable. Then I check for the coefficient of regression model. So here we can see log unemployment rate and log foreign direct investment. So we can see that log foreign direct investment positively influence dependent variable log GDP and statistically significant because p-value less than 5%, and this means that the foreign direct investment influence GDP statistically significant. And the p-value for unemployment rate, the coefficient is negative and not significant, 56.9%, which is not significant, but one variable is significant, which is 50% of the variable are significant, so we accept the model. Then finally we check whether the model has heteroscedasticity or not, after we convert it into logarithm. So we look to the variable here. This is the data. As you can see, the scatter diagram can see that the scatter goes down and then goes up, meaning that there is a sequences, meaning that the model still have heteroscedasticity problem in spite of the transformation of all variable into logarithm. Then we check whether the residual are normally distributed or not. How? Actually, there are two residual. First, I go to analyze descriptive statistic explore. As you can see it here, you have two residual, standardized residual. This is for the before the transformation, and this is after the transformation. So we have to reset the variable here, and then we use the second one, because the first one is for non-log, and the second one after we transform the variable into log. And then we select the second as then we go to plot, select histogram and normality plot, deselect steam, continue, and press OK. So what we have here, we have the skewness for the descriptive and cortices, and if we divide the statistic for sequences by the standard error of sequences and the result between minus 1.96 and plus 1.96, it means that the residual are normally distributed. But if otherwise, residual are not normally distributed. So this is one test for skewness and cortice, divide the statistic for each one by the standard error. But the other thing we are looking for is the mathematical approach. As you can, yes, I want to check it. Okay. Transfer, analyze, descriptive, explore, and this is the standardized. sorry, this is for logarithm, and press OK. Here you can see it, and here you can see the mathematical. You can see that significant p-value is 13.4 and p-value is 15.5 for both Kolmogorov and Shapiro. This means that we cannot reject null. What is null? Null is the residual are not are normally distributed, and the alternative residual are not normally distributed. So meaning that we cannot reject null hypothesis rather than accept null hypothesis, meaning that the residual are normally distributed because p-value is greater than 5% after a transformation. So in this case, the residual are normally distributed after we convert the data, the variable, into normal distribution. So here the same thing for the Shapiro, 15.5 greater than 5%, which means that the residual are normally distributed. Now, I'm going to check here. Okay. Then, the second thing, I choose this test after we convert all the variables are normally distributed, and then we go to the histogram, as you can see it here. You see the histogram. This here you can say probably that the residual are not normally distributed. We check for another graph, which is Q plot of standardized residual. So what does it? We can see that all the circles are not all. We can see that all the circle or the dots are not falling on the line, but they are very close to the line, meaning that we can say from the diagram the residual are normally distributed. Here we can checking box plot, and then we can see whether the data is the residual normally distributed or not. The median is not in the center. This is the median, not in the center, meaning that residual is not normally distributed. But now we up to you to decide, but always we depend on the mathematical approach. After we check the histogram, QQ plot, and then box plot, this is your decision. Always we depend on the mathematical approach, but I can say the residual has become normally distributed after the logarithmic transformation. This is in summary, just to summarize what we just explained. First, we run the regression as GDP, dependent variable, and foreign direct investment and employment in the independent variable. Then we check for normal distribution according to the mathematical approach, Kolmogorov and Shapiro. Then we check also for heteroscedasticity after we're using the plot to see the Z residual and Z predict, and then we decide whether the heteroscedasticity from the scatter diagram exists in the model or not. If the heteroscedasticity exists, then we have to convert all the variable into logarithm and follow the same procedure. Then we will take the decision whether we accept the model or not. So this is all what we have to interpret and explain the outcome of multiple regression model. Please subscribe for more video. Thank you so much.